Alright, we back. More homework. So yeah, I was doing Bayes' theorem. Right. Okay. Bayes' theorem. Kinda forgot Bayes' theorem. Alright, so it's finding out the reverse of the conditional, and you have to know these four things, these three things, right? Is that how that works? No, you have to know these things. Cool. And let me... Yeah, you could know this too. That'll give you insight on this. Right? So you can know all this because it's in the formula. Yeah. That's cool. That's pretty cool. So let's take a look-see on this. So let's say, so we got this, right? We got probability of, this is the probability of rolling a 6, given you have a fair dice, which is 1 over 6. Probability of rolling a 6 on the unfair dice was 2 over 7. And now let's find the probability that you had a fair dice given you rolled a 6. Okay, so I think, so what do you gotta do? You gotta flip it. You gotta flip these things, right? Times this divided by you could divide it by the probability of this, but we don't know that, so we gotta expand it out. This plus there. So cool. Yeah, so let's do that. So I think I already did this, but I'm gonna do it again. 0 point thingy. Okay. So got this times 0.5. Okay. Got that plus this times 0.5. Alright, let's put that in the calculator. Okay. Okay, and we got around 368. 683. 3683, which is what they got. So very nice. Very nice indeed. Okay, so there's a proof. Okay, and okay. So here's what I'm gonna do. We're gonna do this problem. So consider the fair and loaded die. The gambler selects one of the two dies at random. So fair die is half, and not fair die is half chance. And then rolls the die twice. Yeah. The outcomes are independent. So that's good. We can use that. So the first outcome is not 6. And the second outcome is a 6. So yeah. So let's do Y to be that event where the first outcome is not a 6 and the second outcome is a 6. So let's put that. Okay. So let's get that space. So the first roll not being a 6 is that. And the second roll being a 6 is that. Okay, so these are to build the outcomes. Alright, so the probability of rolling a 1 through 5 with the fair dice is 1 over 7. 1 over 6, excuse me. Alright, 1 through 6. And the probability of rolling a 1 through 5 on the not fair dice is 1 over 7. And the probability of rolling a 6 on the not fair dice is 2 over 7. Right. So they're saying the first roll. Alright, let's do this. So we got 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. So this is our event, right? We can condition this on it being fair or not fair, right? And they get different probabilities. So there's 2 different distributions based off what you condition it on. So yeah, let's construct. These are for individual rolls, and we can construct it for this event by just multiplying the 2 rolls because they are independent. So yes, yes. So the probability of getting this event with the fair dice is the probability of all these events, these outcomes, summed up. So let's sum them up. So we got 1 through 5. Well, for the fair dice, all of the chances are equal, right? So it'll be 1 over 6 times 1 over 6 plus 1 over 6 times 1 over 6. So it'll be 1 over 36 times 6, which is 6 over 36, which is 1 over 6. Alright. So now let's find the probability distribution for conditioned not fair. And not fair it's a little more complicated, but it's pretty simple. So if the roll is 1 through 5, given it is not fair, the chance is 1/7. So let's do that. So all these here are below 6. Why did I put 5 there? So all these are below 6. Those all have a chance of 1/7. So let's do that. So we have 1/7 times the second roll, because they are independent. We can do that. If it is 6, it is 2/7. So you multiply that, and how many of these do we have? So there's 5 of these, right? Because it goes here, and then here we just have 2/7 times 2/7 for that. So I'm just gonna type that in the count. Nah, I'm not gonna type that. Screw it. I'm gonna type it because, yeah, bro. So 5 times 1/7 times 2/7 plus 2/7 times 2/7. This is 2/7. So great. 2/7 is incorrect. What did we do? What did we do here? Isn't it 5/6? What? Yeah. So, wait, is this even 1/6? My goodness. What? I did. Multiply the probability of getting a 6 times the probability of not getting a 6. What? I think I did that, right? This is 1/7. This is 1/6. You know, okay, guys, let me redo this. So let's type this out. So we got 1/6 for this chance. This chance is also 1/6. And how many of these do we have? 1, 2, 3, 4, 5, 6. All right. Times interesting. I got the same wrong answer. What am I doing? Is this incorrect? Oh, the first roll is not 6. Obviously, it would include the last one. If it was, my bad. So it's just 5 of these. Whoops. Whoopsies. Okay, yeah, I gotta really pay attention to that. Okay. Yeah, 5/36. Yeah. Yep. Okay. My bad. So, let's see. So, all right, let's do the second one. So this distribution, let's sum up all the probabilities of all the outcomes in the event given this conditional. Here we have we can use these to do that. So the first one has probability of 1/7. and the second one is 6, 2 or 7, and there's 5 of these. Yeah, so let's do that. 10 over 49. Yeah, nice. Okay, and now they're asking to apply Bayes' theorem to this. So I will be using these and these to do that. So yeah. So yeah, let's write this down. So we got this times that, alright. And then we do the same thing except the complement for this. And then that's it. So let's plug in the numbers. So we got 5 over 36 times 1 over 2. Alright. Okay, and then we do the same 10 over 49. Yeah, so we get a thing here. Yeah. So that's cool. It's a 40% chance, by the way. So 40% chance that it is fair given this event. Or yeah. So that's cool to know that. Alright, so let's do this test here. Oh my god. So 1 out of every 1,000 computer chips has a defect. Okay, so the defect chance is 1 out of 1,000. Not defect chance is 999 out of 1,000. I'm assuming. Right, because they're giving an example of that. So let's see. So anyways, the manufacturer has developed a method to test the chips, but the test is not perfect. So if the chip has a defect, it would discover the defect with 99%. So test success given defect is 0.99. And if it does not have a defect, what is this? Wait, what? So I guess I'll put P for positive. So it returns positive with 99% accuracy chance if it actually does have a defect, but it will return not positive. Wait, what? What are they saying for this? If the chip does not have a defect. Oh. So it will return positive if it does not have a defect with this probability. Okay. And then they're saying if the outcome of a particular test indicates that it has a defect, so it'll return positive, what is the likelihood that it has a defect? So they want to know this. What is the chance that it actually has a defect given that the test returned positive? And then these are our parameters. Okay. Wait, let's see. 0.001, 0.999. We just want to put that in there, simplify things a little. So yeah, let's write this down. So we got dish times dish. This goes here as well. And then we got this times this. Alright, let's make sure that's right. So we got dp, let's do pd, so this times this, so 0.99 times this. That's there, and then the other one is 0.02 times this. Okay. Okay. So let's calculate this. So I got a number. That's about my number, so 4%. Wow. It's a 4% chance? Wow, yeah. It's so low, seems counterintuitive, but the test is quite accurate. But anyways, it says it factors in the low probability of a defect in the absence of information from the test, whatever that means. What? I don't know what that means, bro. Whatever. Alright. Alright, well that was pretty simple. Let's do this one. So there's a disease, chance of having a disease, 1 out of 10,000. Alright, and the chance of not having the disease is 1 minus this, so 99,900, whatever. Okay. Okay, so what? So if a person with the disease is tested, it says they do not have the disease, so the negative, with a probability of 0.01. If the person does not have the disease, the test is incorrect with a probability of 0.005. I don't really know. So wait, T is that it's positive? What? Let's. So we got that. So T is that it's positive. So not T. Is that? I don't really know what this here is. It says if the person does not have the disease, the test is incorrect. Oh, so if they don't have it, it'll say that they will have it because that's the incorrect thing. With, wait, what? So what if a person with the disease is tested, The result says that the person does not have the disease with 0.01%. If the person does not have the disease, the test is incorrect with probability 0.001, 0.5. So if they don't have the disease, it should say negative, but that means it'll say positive because it's incorrect. Okay, and that's a chance. So the only thing that is different here is these, which I don't know. I guess, do these have to add up to 1? Or something? Probably not, but I don't really know. I kind of forgot how to do this conditional stuff. Yeah. Let's see. So if a person with the disease is tested, the test result says that they do not have the disease. That's this one, right? Yeah. So they're saying, what is TD if this is a thing? So isn't it this one? Oh, okay. That makes sense. 1 minus this, which equals 0.99. That makes sense. So okay. So we can use these two now to calculate Bayes' theorem. This one, because I wrote that down. So they want to know, so what is the chance they have a disease given they tested positive? And yeah, so that's gonna be 0.99 times this number, and plus this times this. So what is 1 over 10,000? That's 0.001, right? Yeah. So it's gonna be this one. Cool. So that's pretty cool. Cool. We're almost done with this this little lesson here. So I don't know. I was trying to find a good place to zoom in. Alright, so it says one of two biased coins is selected and flipped. Let A be the event of the coin A is selected, and event B is selected right here. So yeah. So oh my god, bro. So they're telling us to come up with stuff. Alright, so let's write these down. So we got 0.4 for that. This is 0.6. So they're saying the probability of heads given A is 0.7. Probability of heads given B is 0.3. And we can infer what happens on tails, because tails is not heads. And it's gonna be 1 minus. So that's all that. So yeah. So here we put heads given B. Here we put the same thing. And here is kind of weird actually. What are they doing? What are they talking about? So this is A is equal to not B. So we're putting the A. So this is 0.7. Oh, there's a different formulation. Here we have biased coins, and this time they're getting flipped 3 times. Interesting. So I hope these are independent events, which they are, right? Because it's a flipping of a coin. So probability of A is that much, probability of B is that much. Alright, so probability of heads given A, probability of heads given B. Alright, so probability of heads given A is 0.4 and 0.5 for B. Alright, so let's do something. What is the probability of getting 3 heads in a row? It is 0.4 to the 3rd power, 0.064, right? And 3 heads given B is 0.5 to the 3rd power, which is this. So yeah, that should be pretty straightforward. So got these 2, and then this one is for A, which is this. Yeah. Okay. So the probability, oh come on. So the probability of having a disease is 9 in 1,000. Probability of not having it is 999,000. Oh, these have to be digits. Oh, okay. So 0.009. And this is 0.991. Okay. So they're saying there's a test. So C is they have the condition. P is positive. Test or whatever. Okay, so positive given they have the condition. Oh, so the probability is incorrect. So if they have the condition, it will report negative this many chances of the times. Okay, so this is the reverse. Okay, and they say that so if the person with the condition is tested, it should return positive, but they're saying that it will return incorrectly. This, okay, and you can infer the correct rate. And then for the without the condition, the probability that is incorrect is this. So this is good because this is the incorrect probability. Given it returns positive even though you don't have it. So yeah. So let's mark this as a comment, I guess. I'm not gonna use it. So So yeah. So the first one is gonna be PC, and these are the same always. And then 0.991 is paired with this one. Awesome. So we got that down. We got that down. Alright, let's see here. So Sally has 2 coins. Alright, the first is a fair coin, the second one is biased. So the biased coin comes up heads. So biased coin, heads given biased coin, they're saying .75. Okay. Heads given not biased coin is half, because that's just how that works. Probability of getting a biased coin, they are both half, because it says she selects a coin at random. So yeah, and then she flips it 10 times. And the results are mutually independent. So the result of the 10 flips is this. What is the probability that she selected the biased coin? Okay. So, okay. So let's calculate this. So we got tails, tails, heads, tails, heads, tails, 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 heads, tails. Right. We got tails, tails, heads, tails, heads, tails, 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 heads, tails. Okay. So we want to know what is the chance that the coin is biased given this outcome. And all we gotta do is find these probabilities. Yeah, so biased given here. Here we do this. Yeah, so yeah. Let's mark these. This is that, and this is that. So let's do the not biased because that's easier. So it's just 0.5 to the 10th. Right, because there's 10 flips. Both of them are equally likely. So yeah, and they're all mutually independent, so you can just multiply them. Yeah, so let's do the biased coin. This one, you just multiply the number of tails thing. Okay, wait. Let's put these things in here. I suspect it's going to be like this. So this is for heads. There's 1, 2, 3 heads, right? And then there would be 7 tails. Okay. So yeah. Let's write that down to our calculator. I'm putting this into a variable on my calculator called x. This I'm gonna put into a variable called y, so it'll be easier to do that. Okay, so here's what we're gonna do. We're gonna do B, so that's X times that, and again, we're gonna have that, and then we're gonna have Y times that as well. Alright, so this, okay. So 0.5 times X over 0.5 times X plus 0.5 times Y. And the number we get is around this much. Oh, 0.0256. Yeah, but we round up, so cool. So that's what I got. Yeah, that's what we got. Cool. So that's pretty cool, right? So given this sequence, the chance of her using the biased coin is like 2%, something like that. So that's cool. Bayes' theorem. Let's do some more. Let's do all of them, but yeah. So let's say that Ariel has 2 dice, right? So yeah. So she has 2 die. Let's get the fair thing and the not fair. Yeah, so she chooses a die at random. So yeah, 0.5. So this is about dice. So landing a 1 through 6 with the fair dice is 1 over 6, right? So it's 1 over 6, which is approximately this much. Right, we could put a 7. 0.1667 for approximation purposes. And she's saying that when it lands on these, it's that chance, and when she lands on a 6, it's this much for the unfair dice. And she's saying, yeah, so they're independent, so I can multiply to find out, doing them in a row. So let's say she got the event E, which is 4, 3, 6, 6, 5, 5. Right. Yeah, so that's the event. So what is the probability of events given fair, not fair, and then we want to calculate what is the probability that the dice is fair given the event occurs. So yeah. So given that it is a fair dice, we just do 1 over 6. Alright, 1 over 6 to the 6. Okay. I'm gonna put that into a variable as well. And I'm gonna put this one into a variable too. Cause yeah. So this one is the not fair dice, so that has a different distribution. So it's these two makes up that distribution. So and it's mutually independent, so I can just build up, multiply everything. So this is probably what it's gonna look like. So I got 0.15, 0.25. So the chance of getting any 1 through 5 is this one. So we have 1, 2, 3, 4, and 2 6s, which is this one. So I'm gonna put that into a variable called y on my calculator. And so to do this, you do 0.5x divided by 0.5x plus 0.5y. Yeah, so that's that. Honestly, I don't think I need to put these as a variable, but I'm gonna do it anyways. So 0.15 to the 4th times 0.25 to the 2nd. Yeah, so we do that. Are these the same chance? 0.15 to the 4th, 0.25 to the 2nd. These almost gave the same chance. They're like slightly different. And then x is 1/6 to the 6. Okay. So I got 0.5 x, and then the bottom is the other thing. So here I got that, which is what they got as well. Very nice. So that's pretty good. That's pretty straightforward. Very straightforward. All right, let's do another one. Oh my god. All right. So the National Fluffer Ball. What is this? Is this real? Oh no, it's just a quiet. All right, whatever. So the National Fluffer Ball Association implements a drug screening procedure to test its players for illegal performance enhancing drugs. So 3% of the Fluffer Ball players actually use performance enhancing. So let's do D for drugs. Don't do drugs, kids. All right, that's that, right? One. Yeah. So the chance that you don't use drugs is the opposite, 1 minus. Okay. So the drugs for the test, a test for the drugs has a false positive. So it returns falsely positive 2% of the time, and a false negative 4% of the time. So let's flip this one, and that's gonna be 1 minus. All right. Okay. So that's gonna be 1 minus. We just take that out. So they want to know, given they tested positive, what is the chance they actually use drugs? So yeah. So yeah, what is the probability that the player really does take performance enhancing drugs? So yeah, just plug in the numbers basically. I'm just gonna do it on the calculator. I'm not really well, actually, should I? Yeah. 196 this. Yeah. Okay, and then I do this times this. Alright. 102.97. Okay, so I got 0.5975. So yeah, cool. Alright. These are that was straightforward. So Okay, so let's just say H for HIV. So 1 out of 10,000 people is infected with HIV, and 99,000 people, whatever, out of 10,000 are not infected. So they have a test where it is positive if you have it. Wait, what? There's a test that in which 2.5% of all people test positive for the virus. Okay. So that is that. Okay, so if a person tests negative, then the person has a 0% chance of having HIV. So if they have HIV, wait, what? Wait, what? So if I'm confused. So the chance of them having HIV, given they tested negative, is 0. That's what that means, right? But that doesn't like help. That doesn't help. So if a person tests negative, then the person definitely does not have HIV. So they want, what is the chance they have it, assuming they test positive? I'm gonna need more like conditionals. I'm thinking. Like, what is this? Like, if they actually do have HIV, what's the chance they're like turning positive? And this one as well. So interesting. Okay, so I have a question. They told me this, right? And they told me this. So the probability of positive is this much for everybody. Okay, and then isn't it, so this is the probability then, right? Like, it doesn't matter what you condition it on, it just always is this much. And for some reason this is 0, but that doesn't help us much. So I mean, this is enough to do Bayes' theorem. Okay, I'm gonna start typing this into the calculator. So yeah, so I'm gonna do 0.025 times 1 over 10,000. Okay. And I'm gonna add it to the 0.025 again, but this time with the other probability. And I got a really low number, 0.00 something. That's not what I got, but so they're saying oh, so that's what I did wrong. So this is 1. Yeah, that's what I did. So what I did wrong was putting it like this, when really it should have been like this. Yeah, that's what I should have written down. Okay, so let's read this again. So they say if a person tests negative, then they definitely don't have it. Oh, cool. That's what this means. So if they test negative, the probability of them having the disease is 0. But I somehow like wrote it backwards. I wrote this backwards. I did this right, the false positive rate, so test given they don't have it, and I did the other things right, but okay. So they started with the intersection. That's their way of doing it. I could have written that down as well. Like the probability of you not testing negative and having the disease is 0. But like this isn't the same as conditional, but what they did is they said this equals the, or like the conditional equals this divided by this, and if this is 0, wait, whoops, if this is 0, then this is going to end up being 0. So yeah, so that's how they got that. But what I don't get is how they like formulated that. Like what I did is so they said if a person tests negative, then they don't have HIV. So I interpreted that as saying, given they tested negative, what is the chance they have it? Is 0. Which this is true, right? This is also another thing, I guess. Maybe. I don't really know. Because if I try to expand this, this would equal H and not P divided by not chance of not P. But I don't know this number. I don't know this one and this one, so I just can't solve for that. And yeah. What was I supposed to do? So like using this, like maybe I wrote this down and then I'd follow this and then I have to find this probability of negative P. Is it the inverse of this? So what? Huh. So they're saying if a person tests negative, then they definitely don't have it. Then they definitely don't have it. Alright, let's try this out. Let's see if this works. So let's do the 1 minus right here. And let's get this one. And let's just see. Excuse me. Let's just see if this makes sense. I mean, it would, because this, if I said that this, you know, this is the probability for this number, then we would have this equation here, and the only way for this equation to be true is if this was 0. So, you know, we would conclude that this is true, right? And then if this is true, we could freaking we could figure out this, because we have the and, right, the intersection, and that's one part of the equation. Because yeah, check it out. Because if I didn't know that was 0, I would just be like, alright, I need the probability of this divided by this, and I have this now, which I know is 0 from this one, and I also have this, so I mean this is 0 anyways, so this would turn out to be 0. So yeah, I could do that as well, right? So I think I think I could have done that as well. I'm not sure if this is a correct thing to say in the first place. Because it says if a person tests negative, then the person does not have HIV. So that's like, given they got negative, the chance of them having it is 0. Like, yeah, I don't know, but we'll see. Alright. So random variables. Let's see. Alright, once we hit an hour. Oh, we hit an hour already. Okay. Ratio. You already know. Alright, let's play growth soccer. This seems like... this seems just silly. So what should I do for this? This is, let's get our traps. Let's do the traps. That sort of worked out. Let's just get a bunch of kills. Like, let's not even play soccer. Let's just get a bunch of kills. Ooh, they're doing some of that. Let's get out of his range. Oh, he was following me. What the heck? Oh my goodness. Alright, let's try this side. So you get some kills. Let's see if we can, anybody hanging onto the walls. Try to get him. Let's just shoot into the direction of the soccer ball. Maybe that will, net us some kills. Alright, let's see. Alright, let's shoot off into the distance. I see stuff happening. There's a Penta there helping out. Alright, let's try. I think there's a person there. Let's trying to locate where these people are based off the bullets. It's a little hard. Okay, we got this dude, which, okay, I don't know where he is, but okay, let's try to get a kill up, please. Oh, we did. Okay, got my reload speed. Oh, I actually killed someone. Oh, that was the #1 person. Interesting. Let's... I want to keep... Oh, there's no leaderboard. Alright, let's see... I almost could have died right there. Let's let this free. Okay. I don't know, let's just shoot in some directions. See if we can snipe some kills. Oh, they're trying to get me now. The guy that I killed is trying to kill me. It's not gonna work. I'm gonna be shooting at you with my nail gunner from a distance. Let's see if we can kill this guy. I don't think we can, but after they get the score, I was trying to kill them. Oh, it's not working. Oh, they're bringing it back pretty quickly, huh? Oh. Oh. I forgot this is soccer. Whoops. Oh my goodness. They're really trying. They're winning, actually. Not gonna lie. Okay, let's try to anticipate something. The dude with the oh, come on, let me get some. You know what I want to get? I want to get the auto. The auto is good. Let's try that. Is there... Well, let's keep the leaderboard anyways. Because... Let's see. The auto shoots by itself. So this will be handy for just aiming. Let's take off the mini-map so we can see better. Is there a way we can get some hits on these people? Am I actually like defending a little? Uh-oh, not really. There's too many players. Oh no, it's over. That's the last goal. Yeah, it's over now. It's over. It's over. Alright, let's see. Can I get some kills? Nah. The big cheese guy. He's pretty good. Bro, I kind of want to play soccer again. That was fun. Do they have soccer still? They might have switched it. Let's see, Growth Maze? What is this? Let's open up the main map. This is, I don't know if, I don't know a good tank for this. I don't really know a good tank. Maybe this one? This is lagging. Alright, let's try to get this. We can sort of do this, right? This is, we gotta get some hits on this thing. Alright, we can do this. This is a part of our strategy possibilities. We just try to get as many hits as we can. Alright, we got something. Alright. Let's try to level up a little bit. Is there a player? I don't know. Alright, let's try to get this one. Let's go to the middle. Maybe there's like a... Let me check it out at least. Let's see what it looks like. Oh, it's another annihilator. Well, that's pretty easy. Let me just try to level up. How about that? Let me just level up by being in the middle. And then eventually I'll be able to just take all the other players' dominators. So yeah, here we go. We can take this one probably. Right. Okay, we got that going. Oh, almost died there. So we gotta get the cycle going. Dodge the bullet. Oh, that's a big... He shoots big bullets. He shoots big bad bullets. Let's make sure he's away. Get away. Alright, there we go. Look. Much better. Let's see if we can ward him off. I don't know if we can do that. He's pretty crazy with those bullets. I think he's gone down to oh. Oh. Okay, I can't even see him. Oh, there he is. Hey there, buddy. Yeah, he's probably gonna take over my my stuff. Alright, let's just continue. Let's continue. Does this one have... What is this? Oh, this is a gunner. That's not good. This is probably not gonna be easy. Yeah. Okay, maybe there's another one. What if we just keep leveling up? You know? What if we just keep leveling? Okay, now it's just me and the other dude. So what I'm gonna do is I'm just gonna reset. Alright, I'm just gonna reset my character. The only way to take all the Dominators is by doing something. I'm gonna do the factory. Alright. So I'm gonna do the factory. The factory probably will allow me to take the gunner Dominator just like how the strategy works. Alright, so I'm gonna hide behind here. Or not. Okay, I'm not gonna hide behind there, that's too far. I gotta go probably like here. So yeah, that's what I'm gonna do. I'm just gonna do this. Right? It's as easy as that. Okay. Might take a second. Let's run them into it a little bit. Oh, I didn't do anything. Alright. So we got that. Let's get some leveling up here. Oh. This always happens. Oh. Okay. Interesting. There's layers nearby. Let me just ignore them. Alright, so my plan is to hide behind this thing. Right? And then just target this. And then that's it. This is how it works. Oh, oops. A visitor is coming. That's not good. There's a boss coming. So we gotta defeat the boss before we... Oh, I won. Okay, well... The factory, that's where it's at. That's where it's at. If there's no players attacking you, you can... The factory will just dominate the freaking... It'll just dominate. So if we hide behind a wall here, this will allow us to defeat the boss as well. So that's pretty funny. Oh, let's see. Oh no. I was gonna defeat the boss. Alright, let's see. Let's play this one. Assault. Alright, let's play. Oh, Growth Assault. Oh my god. Growth Assault. Alright. This is always fun. It looks like the match is almost over anyways. But I kind of want to see what happens. So, I don't know what's going on, but these people are just standing still. There's a lot of people standing still here. What's that about? What's that all about? I don't know, but that's interesting. Maybe they got disconnected. Because that happened to me. I got disconnected. So maybe it's that. Oh my god, look at this. Oh, what is this? I can't even barely fit in here. Alright, let's see what we can do with the nail gun. I'm gonna try to snipe this little thing here. I don't think we can get any hits. Maybe we can, but I don't know. Oh, maybe we did. There's no way, right? There's no way we can kill anybody, right? There's also half the team is trapped on the bottom, which is interesting. I think the assembler is trying to kill them. Alright, let's just keep shooting in this little corner, because I feel like we can get some hits. Oh my god, I kind of want to go to the bottom. I don't know. Let's see if we can try it. Oh. I wanted to go to the bottom. What is happening here? So there's a bunch of nail gunners, there's a bunch of assemblers. This is crazy. I don't think we're gonna... What do we do here? Do we do like a machine gunner type? Oh, alright, it's over. Growth mode is always fun. It's always crazy, but yeah. Alright guys, I'm actually gonna get some food. You know what? Should I turn into a React streamer? Eat some food and react to stuff? I'm thinking about it, you know? Alright, I'm gonna do it. I'm gonna come right back. Okay. And I'm just gonna start reacting to stuff I see. Alright, I lied. End of the video. Peace out, guys.